In this part, we are going to focus on the code for handling all the pixels moving down and checking for collisions, and then some other shorter functions that are quite easy to do. But the hardest part will be making all the pixels move down. So let's get on with it. To do that, we're going to make a function, move pixels down. We're going to go through the array of y positions. So they're all negative numbers. And then we're just going to add 1 to them each time. Now, how many times are we going to have to do this? Well, we're going to have to do it for every drop pixel, just like this. Then the first thing we need to do is just check, is that pixel actually on the microbit screen? Is the value of the y position of all the drop pixels at the index, is it going to be bigger than or equal to 0, which means it's at the top of the screen? But also, it'll go past the screen and it'll be off the bottom of the screen. So the y position must be greater than or equal to 0 and less than or equal to 4. If it is, plot it. That is the x position. And the y position, plot the x position at that value. And also plot the y position. Here we were checking the y position. If the y position was okay at this particular index, each index represents essentially one of the pixels that's dropping, then for that pixel, plot its x position and y position because it will be on the screen. Great. Now, the whole point of the game is to dodge the pixels. And that means that we need to check when that pixel gets to the bottom line, is it going to collide with the other pixels? And so we just need to do another check. If the drop pixel's y position is equal to 4, in other words, it's on the bottom row, then is it the same as the player's x position? And that would be a collision. Is the player's x position equal to the x position of that falling pixel? Because if it is, then there is a collision. And to handle the collision, I'm going to make a function called collision. There. To deal with the collision, we are going to set the game state to 3. So 2 is playing the game and 3 is collision detected. If a collision is detected, we'll just do something simple. It looks a little bit like an explosion. Okay, then we want to show the score. Show number, we will show the score, whatever it is. We then want to give the player a little bit of time to see that. So we'll pause 1 second and then we'll start resetting things because the game is going to start again. Okay. Back to handling the pixels moving down. If we plotted a pixel, let's unplot the pixel above it. We'll make sure I get that in the right loop. The x position is going to be the same. It's just going to be something like this. The y position of all the drop pixels, that value -1. Great. Oh, this is going to create a problem for us because when the pixel goes off the screen, when it goes to position 5, it will not unplot number 4. So in fact, we need to make this a little bit bigger. If we say 5, then it will actually try to plot position 5. And we're going to be happy to do that because nothing's going to happen that we can see. But then it will get to this point in the code where it will unplot the pixel from the last line. Every time the y position of the drop pixel, in other words, it's just gone off the screen, is 5, then we will increment the score. And now we need to move all of those y positions down 1. In other words, we need to increase their value by 1. This is going to happen whatever. So all of this happened only if the y position was in a certain range. But we want every single y position now to increase for every pixel. So we need to have this right out the bottom. And we want to set the value of the y pos of the drop pixels at the index to what it used to be, +1. We need to call the function of move pixels down. Oh my goodness. So you can see this is really fast. It's too fast. To control the speed, what we can do is we can force the microbit to take a break every now and then. And so we can just stick in a pause here. I'll put this on 200 milliseconds. Actually, this is something we want more control over. So we're going to create a variable and we're going to call it game speed. We'll set that game speed to 200. And instead of saying 200 down here, we're going to put in the game speed of 200 there. And now if we play the game, we can see it's happening at a much more reasonable pace. Great. And let's see if we can collide. Oh. We'll have to come back to that to see if that really works, because I'm not sure if I just missed the pixel that dropped. I think it maybe only works if the pixel drops into your place rather than you move into the pixel's place. When the level is ended, what happens then? Well, we don't know when the level's ended. And so to know when the level is ended, we're going to go back to this idea of a clock. And we're going to create a number of ticks. And we'll do that when we make the level. In this function, we are going to make the clock. When we make the level, we're going to set the clock to... So how many ticks do we want? We've got a drop frequency. So every 4 pixels that move down, we're going to get another pixel that moves down. So in other words, we need to say it is the drop frequency multiplied by the total number of pixels to drop. It's not going to work quite so smoothly because the very first pixel starts on the line, but it doesn't really matter. Anyway, so when you make the level, you also make the total number of ticks. We also need to change this value. We need to set the clock equal to the same as it was before, minus 1 tick. And so slowly this value will go down to 0. This is not in the loop. We'll take the clock down by 1. And then we need to have a logic check. If the clock has reached 0, we want to move to level 2. So we need a new function, move up level. Okay, functions everywhere. And we'll call move up level there. To move up the level, the first thing that we need to do is just check that the current level is not the final level of 3. We'll just have a logic check. If the current level is not level 3, it must be level 1 or level 2. And so we want to increment that. We also want to set the game state back to 1, where it will show you what the level is. If you remember, it shows you L1, L1, or L2, L2 if it's level 2. And then we also need to prepare a new level. So we want to call make the level. Because we put the hard work in how we code this particular function, it'll work for any level. And so what happens if you have just finished level 3? Well, let's just show a little string to say, you win. And also, we want to show the score. Well, so really, we shouldn't have put the scoring information into the collision detector. So let's pull it all out and make another little function, show score. And put all that in there. And then at the end of the collision, you want to show the score, so we can call that function there. But also, further down here, when you move up a level, if you get right to the end of the game before you die, fantastic, you should see your score as well there. Okay, well there we are, let's play it. Level 1. Shame there isn't any music, is there, right? Okay. Oh. Okay, it said we won, but we didn't win. It said we won. We have a bug. Okay, we finished level 1.
A few moments later.
Okay, I found the bug. What I did is a mistake here. When you move up a level, it says if the current level is equal to 3. Well, really, it should be less than 3. If it's less than 3, then it goes through this procedure. If it's equal to 3, you win. So the reason the player won is this function was called. It was level 1. 1 is not 3, and so it thought that I'd won. Play the game here. Level 1. Okay, that's it. I won. I won the game. See if it works. You won, and my score is 56. 56. There should be a score of 30 plus 20 plus 10, which is 60. So 60 should be the maximum score.
A few moments later.
Now, I was looking into this and I realized that this was actually because my formula was just a quick formula that I came up with to be roughly the right number, but it is not the right number, and that causes a problem. Anyway, I did some analysis. I'll put it on the screen so you can see. And I actually worked out a better formula for this. One of the problems is that this clock brings every pixel down to a position of y equals 0, but in our code, you only get a score if the y pixel gets to position 5. So we need to let every drop pixel have the opportunity to get to a position 5, which means we don't just need to correct the formula like this, we also need to add on an extra 5. But for us, actually, let's leave a few more ticks of the clock, and then the player can have the sense that the game is over. So I'll just change that up to 9, an extra 4 ticks. And then it will go into the end game procedure. Right, just for fun, we want to put in some sort of secret. So my idea for this particular secret is that when you press buttons A and B, you activate a different mode. So first we'll just check that you're right at the beginning of the game when the game state is equal to 0. And if the game state is equal to 0, we're going to make a fourth game state. I'm going to call this crazy mode. Set game state to 4. The idea here is that you need to be super fast, and so you probably can't be that fast and get to the end of the level, but anyway, it should be a little bit of fun trying it. So set game speed. Now at the moment, the default speed is 200, so let's set it to something crazy like 75. Also, just to signify that we're playing a different version of the game, we're going to go into the main forever loop, and we're going to have another thing here that says if the game state is equal to 4, then instead of seeing the icon with the alien, we can see the skull, because this is going to be dead hard. We just need to check to make sure that the other things are going to work. Right, in this case we do need to change one more thing, because at the moment when you press the A button, it's only going to start the game if you're in game state 0. But now we have this secret mode, we also need to include this. And so we need another logic check. It needs to be either a game state of 4 or a game state of 2. So we just need to replace this one over here too. There we go. The simulator has given us an A and B button. If we press that, then you see we get the skull, and then if we press A or B, it should start the game. Level 1, and this is crazy mode. Oh, that is definitely faster. Ah! Okay, so I died on level 1. We can download this and give it a shot on the actual microbit. Normal mode, level 1. Level 3. Oh my goodness gracious me. Ah. Oh. Okay, I exploded. And I got 44 points. Okay, let's do crazy mode. Ah! got 1 point. Awesome. Okay. Well, there you go. So we've created quite a fun game, I think, given that we've got 25 pixels to play with. But I hope you've enjoyed going through this and learning about microbit. It's a great thing. It's capable of so much more. But all of these projects have really just been focused on using just the microbit and not any extra electronics. Time for you to give it a shot and go and get coding. Guess that's that. It's a wrap.